I made this small tool to simplify programming my microcontroller-based projects, and I want to share this journey with you, show my design iterations, some ideas that worked much better than I could ever imagine, and of course, a lot of ideas that didn't work at all. You will also see some ridiculous 3D prints. So let's get started. This is a microcontroller, or MCU, the core of all modern electronics. These microcontrollers are programmable. You can adjust the function or add new features to your device by changing the program. That makes them universal and flexible, and that's why they're everywhere nowadays. But to write and debug the program, you need some sort of communication interface between MCU and, let's say, your computer. In some cases it could be just a regular USB. For example, I made this board based on ESP32 microcontroller. It has a USB Type-C connector, very straightforward. But not all microcontrollers support USB, or maybe you don't want to have a USB in your design. My favorite MCUs are STM32, and the common interface for these microcontrollers is Serial Wire Debug, or SWD. You can simply add pin headers to the board, as I did here, and connect them to the ST-Link programmer using regular jump wires. It's very simple and it works. This is the way to go if you just started making your own boards. It's a good starting point, but it's not very convenient, as you absolutely can make a mistake in wiring and fry your board. And what if the board is this small? There is no room for these pins. It also feels wrong to solder additional components only to flash the program. So I want a SWD interface that is easy to use, takes almost no board space, and doesn't require soldering. And to be fair, it already exists. This special connector uses spring-loaded pins and various attachments to connect directly to the board. All you need is to place a special footprint of pads and holes on your board. But it's a professional tool, and it's quite expensive, so I decided to make my own version. And I had an idea how to make it even smaller. Most of my boards are rectangular and have M2 mounting holes in corners. They are necessary, but still some board space. What if I can use them as a part of debug connector? This was my first version. These 4 dots are small pads for SWD signals: 3.3 volts, clock line, data line, and reset. The hole itself is plated and serves as a ground pad. This 1mm non-plated hole in the very corner of the board is made for an alignment pin that prevents rotation. I wanted to test the idea as soon as possible, so I didn't think too much about the design and just ordered these boards and some tiny spring-loaded pins. This is my servomotor controller board, by the way. I have a video about this project. Okay, now I need a connector, so I made a very straightforward design. A 3D printed piece with an M2 screw in the middle. Spring-loaded pins with soldered wires carefully glued in place. And this alignment pin, yeah, it's a 1mm drill bit. There is no locking mechanism. I thought it was only a prototype and I would deal with it later. Also, I can just use a nut on the other side of the board. Little did I know what this small thing could actually do. This sketchy prototype worked so well that I ended up using it with these boards and never made an updated version of this design. But what about the locking mechanism? Something that will keep the connector attached and guarantee a proper electrical connection. I learned that it already has one. Just take a look at this. I insert it, press carefully to compress spring-loaded pins, and release. But it just stays attached. And it happens every time. My mind was blown away. It was not planned. It was just a random discovery. And there is an explanation of why it works. The alignment pin and the hole for it are both 1mm with good precision. It inserts freely, but there is almost no extra room. When I release the connector, these pins are pushing against the board and trying to lift the connector. But because all of them are located on one side, it also creates a rotation. And this rotation jams the alignment pin in the hole. So we have a kind of self-locking mechanism. Look what happens when I apply a contour rotation. It just releases with a satisfying click. And this happens every time. And what makes it even crazier is that it works only if the alignment pin is a drill bit. Lately I tried to use a piece of steel rod instead, and it barely works. I think the difference is that the drill bit is made of harder steel, and somehow it jams much better. So I was really lucky to discover this effect. Maybe this locking mechanism is not the most robust in the world, but it's very simple and easy to use. In any case, we need this connector only to upload software or debug the board. So I think it's totally fine. What I didn't like about this connector is that it's quite hard to make one. These pins are not a very common part and they don't have a standard size. Also, the assembly requires fine soldering and very careful work with superglue. Everything is just not good enough to share with other people. Now I want to design a second version that is also easy to make. And the main goal is to get rid of spring-loaded pins. I started by making a new connector footprint for the board. I made pads larger since the space around them is not very usable anyway. I also made a full-size ground pad this time. I ordered a few new boards with this footprint and started working on a new connector design. Since I cannot use pins, I need some kind of a spring that will ensure a good electrical connection. So I started my search of ideas for a spring. And you absolutely can 3D print a spring like this. But I need something much smaller. This was my first attempt. I thought that this structure would move only vertically and act like a spring. And this kinda works. But these legs were too unstable. I was not happy about how this design worked and continued my search for other ideas. For example, I tried to print a really small spring, but it printed poorly and failed instantly. This was another attempt with a slightly larger spring. Didn't work either. It was too fragile and unstable. And finally, I made some progress with this spring. It works very well. It's very stable and still it's just one solid piece of plastic. That was exactly what I was looking for. At the same time, I had another cool idea. I can use regular jump wires as contacts for the connector. These jump wires are very common in hobby electronics, so everybody has them. And if you look closely at this pin construction, you will see a tiny plastic lock. This lock could be opened with any sharp tool to extract the internal part. And now I can just make a similar plastic case as a part of the connector and place the wire inside. I combine these two ideas and make this prototype. It has 5 holders for jump wires, 5 springs, and it's just one solid part. I still can't believe that we have tools to manufacture something like this at home. What a great time to be alive! I inserted one wire here so you can understand what I was talking about. This looked very promising, so I designed the next iteration. I improved the spring stability even more, added a place for an alignment pin, and made a handle that also protects the springs. Unfortunately, I had a printing defect this time and the print failed. This print has a lot of thin parts. Some parts are just 0.5 mm thick. It's quite hard to print and it's fragile. Could I fix that? Maybe. But there was another thing that made me upset. How in the world did I turn this into this? Can we even call it an improvement? It's such a big difference in size and complexity, and it's still not even done. And you know, for me it's a very common story in engineering, especially in software. Let's say you are trying to solve a problem. You have cool ideas, but you are facing one issue after another. You are trying to solve them, but with each iteration your design becomes more and more complicated and insane. And sometimes, Even if you spend a lot of time and effort, even if you feel that you are very close to the result, you need to take a pause. You need to ask yourself, is it still good enough? Is it still justified? What if it turned into over-engineered piece of garbage? Don't get me wrong, it's not easy. It's always sad to take hours of your work and just throw it away. But sometimes you need to step back to get a better result. And I'm glad that I made that kind of decision in this project. I gave up my super spring idea and made a completely new design. The new idea was very simple. These strips of plastic bend and act like a spring. And it almost worked. So after 4 extra design iterations, I got my final design. It even has a small handle to hold it with 2 fingers. I will show you how to assemble one. First, we need to print the main part with PETG filament. The filament should be dry. That's the difference between wet and dry filament. Now take a jump wire, remove the housing and insert it like this. Take pliers and bend the tip of the pin. It should look like this. For the alignment pin, I use a piece of steel rod. But as I told you before, it doesn't hold as well as a drill bit. So to fix that, we can just slightly bend it inwards. And finally, place a screw in the middle and make it about 2 mm long. Let's test it out. It holds well and provides good contact. The only issue is that it takes some extra space around the footprint on the board. Ideally, I want to be able to place electrical components on the board right after the connector pads, and with this design it's not possible. Let me know if you have an idea how to make this connector even smaller. And you know what's funny? Compare it to my first unsuccessful design. They are quite similar, right? So yeah, I did a lot of unnecessary work here. But I hope that at least it was interesting to watch. If you like this connector and want to use it in your projects, check out the description. You will find all design files there. My name is Dima, and if you enjoyed this video, give it a like and subscribe to see my future engineering projects. Have a great day!